Look at the sheer processing capability of modern artificial intelligence. It can parse millions of data points, write code, and generate complex strategies in seconds. But despite this velocity, it operates inside a closed loop. It cannot physically purchase a server, subscribe to data, or hire a contractor. To participate in commerce, our current financial infrastructure requires a human identity. A participant needs a government-issued ID for verification, a physical address, and the ability to navigate banking operating hours and high-fee clearinghouses. An AI has none of these. Even if a machine could somehow open a traditional bank account, the speeds are completely incompatible. An AI generates responses in milliseconds, while traditional wire transfers and bank settlements often take days to clear. Without a financial passport native to its own digital environment, artificial intelligence remains a highly capable observer. It can advise us on what to buy or how to optimize a business, but it cannot execute those transactions itself. We are now seeing the development of AI agents. These are proactive programs designed to take a general goal from a user and figure out the individual steps required to achieve it, operating entirely on their own. If you ask an agent to build and launch a functioning website overnight, it needs to rent hosting space, purchase access to proprietary data streams, and pay for software APIs. All of these actions require immediate financial transactions. To successfully complete these tasks, the agent needs a payment system that can handle fractions of a cent, programmatically, in the span of a few milliseconds. This flowchart illustrates what happens when an autonomous machine attempts to process a microtransaction through a legacy credit card gateway. The request immediately halts. The banking API demands verification before proceeding. The denial happens because the system is specifically asking for a human social security number or a verified physical address. The machine lacks this documentation, forcing the request into an endless failed loop. We have successfully engineered digital workers capable of managing complex logistical tasks, yet we have not provided them with the functional digital wallets required to actually pay for the tools they need to do the work. Blockchain networks offer an alternative architecture. They operate 24 hours a day, 7 days a week, relying on programmable code rather than traditional banking hours and human oversight. This network map shows how a decentralized ledger removes the need for a central human intermediary. Because the system relies on cryptographic consensus to verify transactions, machines can settle payments directly with other machines. Different networks offer distinct advantages for this process. Ethereum utilizes robust smart contracts to execute highly complex machine agreements, though its heavy processing load currently results in slower throughput. Conversely, networks like Solana and Avalanche are structurally optimized for raw speed, pushing data packets through streamlined pathways at much higher velocities. For operations requiring immediate currency conversions, Stellar's architecture is specifically designed to swap digital assets seamlessly across geographic boundaries. And for the specific requirement of processing thousands of fractional payments simultaneously, the XRP ledger was engineered from its inception to handle high-volume, low-cost microtransactions with minimal friction. Recognizing this specific utility, Ripple has recently announced initiatives aimed at integrating artificial intelligence directly with these decentralized payment rails, building the actual plumbing for machine commerce. When evaluating these networks in the context of autonomous agents, we have to look past the speculative trading markets. These are competitive infrastructure engines, each attempting to solve a specific data transfer problem. But possessing a functioning technological engine is only half the equation. Having the capacity to process AI commerce does not mean a system is legally permitted to operate on the global market. Major corporations are currently hesitant to integrate artificial intelligence with decentralized payment networks. The strict legal requirements surrounding financial compliance create a profound ambiguity when machines are the ones spending the money. Corporate liability acts as a massive barrier. Even if an AI agent can perfectly execute a supply chain purchase, a company cannot deploy it if the legal department cannot guarantee the transaction complies with federal law. This specific legal vacuum is what the U.S. Clarity Act is designed to address. The Clarity Act formally mandates that the federal government study and establish standardized definitions and frameworks for how blockchain technology interacts with existing financial structures. By replacing regulatory silence with clear, government-backed definitions, enterprises are given a concrete set of rules to follow. This drastically reduces the compliance risk of adopting new financial technology. This schematic demonstrates how the legislation acts as the critical bridge. It connects the computational capabilities of the AI agent with the payment rails of the blockchain, all while locking into established corporate compliance standards. The functional result is that an automated financial transaction executed by a machine can now be clearly audited, tracked, and legally justified by the corporation deploying it. This legislation serves as a societal software update. It provides the legal viability required to actually turn on an autonomous machine economy. As these frameworks take effect, the cryptocurrency sector transitions away from an unregulated, speculative trading environment. It becomes a highly regulated, highly standardized utility layer, used primarily for background machine operations. Under these clear legal ground rules, the question of which specific blockchain network dominates the market becomes secondary. What matters is that a legally viable ecosystem exists for these transactions to occur. With the legal boundaries firmly established, developers can push the limits of what AI agents can accomplish, knowing the financial actions those agents take are operating within a safe, compliant structure. We are looking at the foundation of a parallel global economy, one that operates autonomously in the background, processing millions of microscopic transactions per second. This system relies on three distinct pillars. Artificial intelligence serves as the computational brain, blockchain networks provide the necessary payment rails, and government regulation writes the rulebook. Proactively establishing the legal rules for how machines move money is the only practical way to ensure that automated technology remains completely aligned with human intent. The question we have to answer next is how our traditional economic models designed entirely by and for humans, will adapt when millions of non-human entities begin transacting independently, long after the rest of the world has gone to sleep.